In this video we will look at some special substitutions. We can use those substitutions to compute integrals of functions containing expressions such as the square root of a squared minus x squared, or square root of a squared plus x squared, or square root of x squared minus a squared. For example, if we want to compute this integral, we can use the substitution x equals 8 times sine t, where the constant a is 1. Similarly, if we want to compute this integral, we can use the substitution x equals 8 times tangent t, where the constant a is 1. If we want to compute this integral, we can use the substitution x equals 8 times secant t, here also the constant a is 1. Let's look at those examples more closely. To evaluate this integral, consider the following substitution. X equals sine t. Then, dx equals cosine t dt. Notice that x is between -1 and 1 because this is the domain of this function. Now, substitute here, in place of x, the function sine t. And replace dx with cosine t dt. Further, replace the number 1 with the Pythagorean trigonometric identity. And cancel the factor cosine t. This gives us the integral sine squared t dt, which can be evaluated using the half-angle identities and which is equal to 1 over 2 times t minus 1 over 4 sine of 2t plus c. But we know that sine of 2t equals 2 sine t times cosine t, and cosine t equals the square root of 1 minus sine squared t. Finally, since t is arcsine x, it follows that the initially given integral is equal to 1 over 2 times arcsine x minus 1 over 2 times x times the square root of 1 minus x squared plus c. To evaluate this integral, we use the substitution x equals tangent t, where t is between -pi over 2 and pi over 2. Then, dx equals secant squared t dt. When we substitute for x, we get the integral of cosine t divided by sine squared t. We evaluated this integral by the standard substitution u equals sine t. And finally, we replace sine t by this expression, to conclude that the given integral is equal to negative square root of x squared plus 1 divided by x plus c. We can check that the derivative of this function is the given function. To evaluate this integral, we use the substitution x equals secant t. Then, dx equals secant t times tangent t dt. When we substitute for x, we get the integral of cosine t, which is sine t plus c. It follows that the given integral is given by this function plus some constant c. We can check that the derivative of this function is the given function.